Hello, everybody. My name is Max Phillips, and you are in the talk, What is Generative Art? Future Max is going to post a link to the slides right about now. You can follow along if you want. They're published as a GitHub Pages site. So any images or links that you see in there, you can click on and explore more about the information we're going to cover. So let's get started. This is Generative Art. Circlish Circle by Aaron Penn. You can see that it's composed of some circles arranged horizontally or vertically in stacks. Here's some more generative art, Efflorescent by Mitchell Flout. This one uses fractals and very vibrant colors. Here's the piece, Loxodography by Tyler Hobbs. We can see this one kind of infers depth or texture with the shapes that it uses. Here is an example for palettes by Ketil Golid. This one, if you click on his name there, it will take you to a live client that you can mess around with and generate your own version of each of these little cubes. Oh, not sure how that one got in there, but so this is a piece by some guy called Max Phillips. It looks like it's a representation of the night sky. So of course, we'll have a definition slide for generative art. These two definitions come from a couple of different papers that are pretty widely cited within the community. So the first is Philip Gallanter. He's a professor, I forget where. His definition basically incorporates the fact of art practices where artists use systems, whatever kind of system that may be, and the system runs autonomously, contributing to the end goal of the work of art. And then a very similar definition is suggested by Margaret Bowden and Ernest Edmonds. Margaret Bowden is an academic and Ernest is an artist himself. And their definition of generative art, again, it just encompasses the fact that a process running outside the artist's control is acting on the art. So in our case, the system or process is going to be a computer. That's what we'll focus on. And of course, computers are fairly good at interacting with various different media. The most straightforward one, for example, would be like digital renderings. So the computer can put pixels onto a screen. That's something that computers are extremely good at. Computers can also generate sounds or combine sounds in new ways. Computers can do virtual reality. So instead of a flat two-dimensional screen, we can make generative art three-dimensional. And then of course, outside of like the electronic computer realm, we can do generative art made by a sculpture or a robot. We can combine all of these. So the example you can see here is an installation where you can walk through a room with projected art onto the ceiling and floor and walls. Now that we know what generative art approximately is and what kind of media you can use with it, you may be wondering, well, how long has generative art been around? So the answer is, depending on your exact definition, for quite a long time. So this is a tile that was found in an archaeological dig in the late, I think it was 99 or so. The archaeologists discovered this tile, and we can consider this to be generative art since the system is the symmetry or the pattern that the tile is present in, and that was acted outside of the artist's control, who was actually doing the carving themselves. And this is dated, I think, maybe even 25,000 years ago is what they were believing it to be. So let's jump forward quite a bit into more recent history. Here's an example from the 18th century of musikalisches Würfelspiel. If anybody actually pronounces German, I'm sorry, I'm sure that was terrible. So this is the idea of a musical dice game, is the literal translation. And it's the idea that pre-composed music can be arranged randomly by the roll of a die and then played in a certain order to amuse party guests or whatever they did in the 18th century times, who knows. And then just across the century line, one of the more prominent historical examples would be the Jacquard machine, which is the fancy loom. So this really increased the complexity of designs with which a human could weave. And it used punch cards. So that would be the system in this case of the art. The punch cards would define what the patterns are. Somebody can run it, and that would be the process of creating the artwork. And then this is where we get into the good stuff. So this is in the 60s. Computers have been around. Computers are kind of more mainstream now. And in Germany, this guy, George Nies, writes a computer program that controls a mechanical arm controlled by like tape rolling back and forth. And so this arm drew lines. In this case, one of the pictures that you can see is kind of a cross of different lines. George and his buddy Max Bense exhibited this art in a gallery, and the actual artists of the time weren't too thrilled about it. They felt that it was kind of taking away the skill that's required in order to actually aesthetically judge art and what is good and what is bad. They felt that it was a bit of an affront. So if you take a look at that link there for NAIC 2005, that's a memoir of somebody who had attended the gallery opening. It's a pretty funny read. And this is another example similar to the musical dice game. So this is a novel written in 1969. It comes with an introduction and then conclusion, and then the rest of the novel is 27 different sections that are meant to be read in a random order. So depending on which order you pick to read the novel in, you might have a different interaction with it or think about it differently. And then jumping up a little bit even more, in the 70s, Brian Eno was writing a lot of generative music. So in this case, Ambient 1, he has various different ambient, it's a series of records. And he creates each track by looping different sounds, somebody's voice maybe, or a different piano loop or something like that, and then playing them on top of each other with different timing. So the song may be like 40 minutes long, but the patterns won't repeat exactly throughout the whole song. Here's an example. So The Blind Watchmaker was a book by Richard Dawkins, and it came with this accompanying computer program that could create these little pixelated, they're called biomorphs. So you can generate like a tree, or it looks like some bugs, different fish down at the bottom. So these would be created by a set of rules that the pixels are arranged onto the screen respecting. And then here's kind of a 3D version of that previous one. So the Galapagos was an art installation by Carl Sims. In this one, gallery attendees could select which types of organisms they found interesting or appealing. And then those organisms would continue to generate offspring. And then in 1998, generative art conferences got started. These are held in Milan, I believe. They've been yearly, organized by people in the community, and then you can go and share what you're doing in the field, think about and listen to what other people are doing. Here's an installation from 2000, and this one has gone on for a bit of time afterwards. So this is a starfish projected from overhead, and you can actually interact with it by extending your arm out. And if you extend your arm slowly, the starfish will kind of, shake your hand a little bit. If you jab your hand into the starfish, it will recoil and try to run away from you. In 2011, R Generative was started. This is a subreddit for generative art. People post what they're doing on here, and you can kind of check out what's going on. This is a screenshot from very recently, so it's still going 9 years later. And then this is an example from just last year. If you're familiar with Aphex Twin, he makes techno music, and then he has this guy Weirdcore who helps him out with live visuals for his concerts. So those faces are actually Aphex Twin's face splayed randomly around the screen. And you can see the video feed is in that little light green grayish block there. So after all those examples, let's actually take a step back and pick out what we think truly composes the field of generative art. So Max Benza is the guy who I mentioned earlier at the Gallery Open. He wrote up this document, Projekte Generative Ästhetik. His thing was you can basically create a set of rules. So the conditions for the composition are defined by the programmer. And then you'll apply different conditions on top of those rules. So that would be like introducing random generation or introducing like genetic selection, some things like that. Then you can read through that rest of the quote there. Basically, he says, to make an aesthetic object, you won't be unpredictable, but you can also plan for that unpredictability. And then even if the machine is generating millions and millions of these objects, they're still appealing to a human. Going back to Margaret Bowden and Ernest Edmonds, this is one of the research pairs that we heard a definition from earlier. So they build up a little bit on that. They talk through some of the different ways that those fitness functions can be applied, whether that's like a computer function or whether that is somebody judging the art and manually selecting which one appeals to them, and continuing to iterate on the appealing processes. And then finally, Philip Galanter proposes this complexity theory as a framework for evaluating generative art. So he says that both perfect order and perfect disorder are fairly boring, and computers are actually really good at both of those things. But what we really want to have interesting and aesthetic art is a mix of order and disorder. So that's what he calls effective complexity. So a human needs to get involved in order to coerce a computer to make some ordered pieces and some disordered pieces and combine them harmoniously. Great. So now I hope we've worked through a little bit of what generative art is, and let's talk about, why it's appealing or why it's awesome. So it's super fast, right? Your computer is orders of magnitude faster than anything you could do. Even if you wanted to do something as small as like drawing a star on a Post-it note, a computer can do that way faster than you can, let alone making a full 20-foot by 10-foot wall of color. A computer is going to be way better at that than you are as well. It's also adaptive. So when I say that, I mean, if you end up with an artwork that you kind of like, you've got all the computer code for creating it, so you can make slight tweaks to it, and then make another piece of art that's very similar, and maybe one that's more appealing to you. That's a lot easier to do than like starting from scratch on your oil painting. And then maybe the most important thing is that computer art doesn't require you to actually be a good artist. Your computer can draw a perfect circle. It doesn't matter if you can. Of course, there's some problems with generative art compared to traditional art. So maybe the most pressing is the fact that is the computer art, what is it, right? Is it the code behind the artwork? Is it the final rendering? In this case, the references there for Aaron and Emmy, those are two different computer programs that can generate art and songs respectively. So is the program itself the art, or is the output the art? That's a question for philosophical musings. And then the note about artwork being perfectly reproducible. So if you have introduced random variations into your art or anything like that, if somebody knows the same input state that you gave to those random number generators, they can exactly recreate your art. So if we wanted to do that by hand, it would involve like, duplicating somebody's painting manually. But with a computer, it's a bit easier to make exact copies of something. But that said, I think generating art is great. It's a lot different muscle set than what you might be doing as a software engineer. I thought these quotes were great. for even when a programmer has written explicit step-by-step code, he or she does not necessarily or even usually know the outcome. And then computer artists and computer scientists know from the experience of writing algorithmic code, you feel like you're in control, but that really doesn't carry over to the fact that when you're generating art, if you create an initial set of rules and let the computer do its own thing, it's a completely different experience and really interesting to me as kind of a brain break type situation. So let's actually get into some of the ways we can generate art. These are a couple different tools. Blender is a 3D modeling and rendering tool, processing, and P5.js. Processing is a language for generating art, and P5.js is a JavaScript port of it. I'm sure plenty of people are familiar with D3. That's another JavaScript data visualization tool. And even SonicPy, if we remember from DevCon last year, there are a lot of live coding environments that can be used for generative art. So the one that I like to use is P5.js. It's free, it's open source. There's a web editor. Then you can pull the library in either by downloading it or from a content delivery network. And then on top of the core library of P5.js, there's a bunch of community libraries that you can build to. And since it's JavaScript, you can interact with plenty of other different libraries that other people in the community have created. So let's jump into a demo. I've got 3 different things to show off, and we'll play those out and hop back here. So let's talk through an example of generating art with something very simple like a line. In the naive case, we could define a line by its start and end point and have a straight line drawn in between those 2 points. That's great, but it's not particularly interesting. So we can use more advanced algorithms to control how our lines look and get more interesting results that way. You may be familiar with, for example, Bezier curves. That's an example of one line control algorithm. And in this case, we're going to use an algorithm developed by this guy, Chaikin. So the file you can see right now is like almost a library that I've defined using a couple methods that implement the Chaikin algorithm for controlling lines, and then one method here for drawing a line itself. And this is a recursive algorithm. So you can see if you call Chaikin curve, we'll keep calling it until we hit our endpoint. And then Chaikin curve calls out to Chaikin cut. So the idea behind this line control algorithm is that we'll take a line, break it up into 3 different segments, and then use the 2 points that we divide the line into as control points to draw a curve. So I know I'm not explaining it super well, but we'll see how it looks in practice. In this case, I'm going to use a client that I wrote, just some JavaScript and HTML, and show the results that way. So we have our processing setup and draw methods, and we have some initialization of control points, and we're going to draw one line. So we'll flip over to the browser, and we can see here a line drawn according to that control algorithm. We can generate a couple new ones. In this case, the input points are distributed randomly across our whole canvas. We can add new control points to the line with the up arrow. We can take them away with the down arrow. And then a cool thing here is we can see the history of the algorithm. So each of these lines represents one iteration of the Chaikin algorithm running. And then you can kind of tell as more and more iterations occur, the line becomes more and more rounded. So if we turn it down, so here we're running the algorithm once, here we're running it 9 times, and you can see that's almost, perfectly curved. So great, these lines are kind of cool, but not particularly interesting. We can combine them in a couple different ways. One of the ways would be something like this. So in this case, I've kept my gray background, I've kept my black lines, and then we're iterating a couple hundred times, drawing a line during each iteration. And at the beginning, we're letting the lines spread widely across from the center and tightening that up as the iterations go. And we're also transforming the line from black to white. So it takes a minute to regenerate these since there's a lot of processing happening. But here's a couple different examples of what that looks like. Next, let's talk through some art with a more real-life subject matter. So I love going outside at night and looking up at the stars, and I thought to myself, what's the only better thing than doing that in purpose? Of course, it is recreating it and looking at pictures of night sky on my computer screen. So what you see here is the code behind that night sky image I showed at the very beginning of this presentation. And I'll talk through what each of these functions is doing, and then I'll show you a couple of the different parameters I wrote so we can tweak the output of this program. So we're using a lot more rate generation in this compared to the previous example, as we need to pick colors and points and gradients instead of just points like we did for our lines. And then we're going to draw the sky and draw some stars in the sky. So the star algorithm is a lot simpler. We'll set our fill color to white. We'll create the input space for our stars. And then I just went on Wikipedia and Googled which types of stars and how big they should be. So 96% of all the stars are going to be pretty small. 3%, 4% almost are going to be medium-sized, and a very few stars are going to be large. And that's going to be what we're set on top of our sky. So to do the sky, we're picking a couple of different, we're dividing the canvas into a few different sections vertically, and then using gradients to transform colors gradually. We'll start from very much black at the top and get lighter and more saturated color as we go down to the very bottom. And then these are helper functions. Here's one that deals with gradients. Here's one that picks a random hue. In this case, we're also going to pick our gradient colors at least within a third of the color wheel next to the previous color, just to keep the color scheme a bit more organized. And here's another gradient helper function. So in the browser or in the client, it looks like this. You can see here, we're starting from black, going through, it looks like maybe a very dark purple, into a green, into a blue, into another lighter purple. So we'll regenerate this a couple of times. Here we picked a purple and a green almost, some reds. We can make it darker, so make it more late at night with this key. We can lighten it up, make it earlier in the evening or more of a outer space vibe. And we can add stars. If we press, sorry, this is the key for removing stars. So we're taking a bunch away here. And then we can add a bunch of new stars if we draw this way. And these settings are persisted. If we regenerate, the new skies will have a lot of stars as well. So now we're going to generate some art and have audience participation to get to our final result. So what you can see right now is the P5.js web editor. It defines these setup and draw functions by default. And then I've included these two other functions for some color picking that we'll use. So you can think of this as kind of like a library that we're relying on. I'll hide them for now since we don't particularly care about them. So if we run the sketch as it is now, all that we'll see is a gray square. Canvas is 400 pixels tall and 400 pixels wide, and the background is set to 220, which represents gray in the RGB color space. So let's switch over and get to our initial state. We'll replace the setup and draw functions. And if we run this, we can see now that a square appears in the middle of the screen. So the first decision point that we want to make when we're generating this piece of art is what kind of shape should we use? And to do that, we can rely on this function that I've defined called draw shape. Right now, it's drawing a square. So we have a couple different options, and we're going to let Matt pick which shape we want to use. So Matt, would you like a square? We can do a diamond by rotating a square. We could do a circle. We could do a cross type thing. We could do a triangle. Or you can put me on the spot and ask for any other shape, and we'll work on that.
How about a diamond?
Okay, cool. So we'll uncomment this code and get rid of everything else that we don't need. And I'll explain a little bit about how this is working. So before we saw that there was just a function called towards a square. That's a special instance of processing's rectangle, which has equal width and height. So to rotate that, we're using translate to set the processing origin, calling the rotate method, and setting our rectangle mode to center. That means the rectangle will be rotated around its center point. Cool, so we've got a diamond as our shape. Let's go on to the next couple of decisions that we can make. So it's black right now. That's fairly boring. So we can pick a different color. We'll have Melanie pick a color that we want our shape to be.
Let's do my favorite color, purple.
Okay, great. So when we're dealing with colors and processing, there's a couple different modes we can use. The background that I showed earlier used RGB, which is fairly difficult for humans to conceptualize. So in this case, I've set the color mode to HSL, which is hue, saturation, and lightness. So we can see in this case, our color function is passing in 3 arguments: hue, saturation, and lightness. The hue is a value between 0 and 360 degrees, with 0 representing red, 120 representing green, and 240 representing blue. And then saturation and lightness represent how saturated the color is, or kind of how almost bright that it is. And lightness is a scale of from white to black. So the color that we're doing right now, since we have our saturation of 100 and lightness of 0, that means we're at black, no matter which hue we pick. So if we want to do purple, we can think about that on a color wheel from red, green, and blue. So purple would be between blue and red. So that means between 360 or 0 and 240. So we could do something like, let's try 270. We'll see what that looks like. And I need to change my lightness to about, we'll do something like 50. So halfway between perfectly dark and halfway between perfectly light. That's kind of an okay purple. We might tone down the saturation a bit. That didn't change much, so maybe we need to pick a different angle slightly. Do you like a reddish purple or a bluish purple?
Bluish purple.
Okay, so we'll lower this a bit, get closer to blue. It's almost too far. Let's see. Let me know if you like any of these colors.
That one looks good.
Change this.
Oh yeah, I like
it. More toned down.
Yep.
Perfect. So we've got an angle of 265, which represents approximately purple on a color wheel. We have our saturation set to 50, and we have our lightness set to 50 as well. Great. So now, instead of a white background, let's make that a bit more interesting as well. So we can do kind of a relative background. We'll use our foreground color and make a relative background shade. So we'll have Whitney help us pick which color the background should be. And then by default, we'll use the same hue that we've used here, and we can tweak the saturation and lightness of the background in order to make it look a bit more visually appealing. So we'll add in a call for the background of our sketch. If we run it by default, it's going to be kind of grayish. So Whitney, do you like a muted background, a lighter background? Do you like a darker background? What should we go for?
Let's go with a lighter background.
Okay, so in that case, we'll keep the saturation the same right now, and we'll add a little bit to the lightness. So something like this we could do. We could also make it a little bit less saturated. That'll make it a bit more pastel. Try something like this.
I like that. I think that looks good.
Okay, great. So we've got our primary color for the shape themselves, and then we got a background that's less saturated and more light. Okay, so now instead of just one shape, it's probably going to be more interesting if we have a couple or quite a few. So we can change the amount of shapes we draw by editing this parameter of the draw shapes function, which is the grid length. So we're going to keep our grid in a square, and this is the width of each side of that square. So Dana, we'll have you pick how many shapes you want to be in the grid.
Can we do 9?
Yeah, let's try 9. This will be pretty wide and go all the way to the edges of the screen. Does that look kind of like what you had expected?
Yes.
Perfect. Okay. The next thing we can do is modify how closely these shapes render to one another and how big they are relative to the frame. So we'll go back to Matt then. And then the next way we can do that is by using the next 2 parameters of this draw shapes function. So by default right now, the length of each shape is the width divided by 9. So the width is our whole view here. So each shape is 1/9 of the total size. And then the space between the shapes is 1/18 of the total size. So Matt, do you like the ratio that we've got here? Do you want the shapes to be bigger? Do you want more space in between each shape? Or smaller and less space in between each shape?
Yeah, let's do smaller and less space.
Okay, so we can make that happen. So if we add a couple of parameters here. So if we do something like width divided by 18 for the length of the shape, that will shrink them down like this. We might need to make our grid a bit bigger if we liked what we had earlier about the shapes overspilling. We could try something like some more space in between. That means we should go as a bigger number here. Something like that is what you're thinking?
Yeah, that looks good.
Okay, cool. Should we tweak it a little bit? Dana, do you want those shapes to overhang the edges like they were before?
I like that. I think it looks nice.
Okay, we'll keep it like this grid. Cool. So the next thing we can do is add some slight variations into the color we have here. So it's pretty boring to have everything be exactly the same shade of purple. So we can go down to this pick color function. So right now it's just returning a single color all the time. There's a couple different tweaks we can do to make this a bit more interesting. So let's replace our pick color function. And in this case, so I'm adding a couple of things here that I'll comment out for right now. So we're basically going to split out our hue and our saturation, or excuse me, our lightness, in order to make the color that gets returned more interesting. So right now it'll be the same, but we can use some of those functions I defined earlier to pick some interesting colors relative to our own color. So there's a couple options here, and you'll see that we're calling random now. So I'll go back a little bit and talk about that. So processing P5 uses the concept of random generation, just like almost any computer system does. We can seed the random generator. So in this case, I have it set to some random number. So when I make random decisions by running the sketch, the same random decisions will be made each time until I change the seed. So with that in mind, we can pick, so here's an example of using tertiary colors. So those are colors 30 degrees apart on the color wheel, if I remember correctly. And secondary are colors 60 degrees apart. And we can also modify the lightness a little bit too. So let's take a look at what that might look like. So if we pick colors randomly using tertiary colors, so we can pick a random tertiary color from the color palette, or we can pick a random secondary color. I had to do a little bit of troubleshooting, so that's why the footage jumped here. And in this case, we're picking random tertiary colors. So we started with purple. Negative 30 degrees is probably this blue color, and positive 30 degrees is probably more of this reddish purple. And then I'll rerun the sketch, and we can see that each random decision that got made in order was still made in the same order each time we ran it. But if we do change our random seed to some other numbers, in this case, the random decisions will be made in a different order. So we can take a look at our secondary colors instead of our tertiary. So in this case, the purple starts as the center as well, but the reds and blues are farther apart. And then we can also mess with the lightness of the color if we want to do some sort of monochrome color scheme. So I need to fix the error that I mentioned earlier on this one as well. In that case, we can see that these are all purples now, but they're still either lighter or darker. So in this case, I forgot whose turn it is. I think it's Melanie's turn to pick which color palette you want to use, like a monochrome one like this. Do you want to use the tertiary colors or secondary?
I liked the tertiary. Let's do that.
Okay. And we can even actually combine the tertiary and the lightness a little bit. So if we switch back here, do something like this, where quite a few different colors are presented.
I think that looks cool.
Perfect. Okay. So right now we're picking a uniform distribution of the different items that we are choosing for our hues and our lightnesses. So the call to random here is what's referred to as a uniform distribution. That means each option is equally likely to occur. So that's kind of okay, but it might look a bit nicer if we wanted to change a random distribution and make things a bit more aesthetically pleasing. So we can do that with a Gaussian distribution or a normal distribution. So I'll show an option of both of those two, and then we'll have Whitney pick which one she thinks looks more aesthetically pleasing. So I'll grab some code here and paste it in. In this case, instead of calling that random function, we're calling random Gaussian. We've got the tertiary options still selected. We can do the same thing for our lightness. And the Gaussian distribution is basically, so it's normally distributed around a single point, which means values that are close to that first value that you pass in are more likely to be selected, and values that are far away from it are less likely to be selected. So this will keep our purple as the most common color, and it will leave the accents to be a bit less likely to occur. So if we run this, we can see now that there's a lot more purples here, and we have only a couple of these accent colors and then one of these really light blues. Do you like that better, Whitney, or do you like the uniform distribution?
I think I like the uniform distribution better.
Okay, great. So we'll switch back. One comment here. And so you'll see the Gaussian distribution and the uniform distribution both pop up quite a bit in various generative art. So this is what we had before. Cool. And then the last thing we want to do here is we can give it a bit of depth to our art by adding a couple, like a drop shadow accent color or something like that, just to make it a bit more visually appealing as well. So we can do that here. We'll go back and take a look at our actual draw shapes function above. This code is what's making each diamond show up on the screen. So if we duplicate this and offset the diamond slightly and draw the background diamond first and draw the normal diamond on top of it, it will look a bit like, it'll give a 3D effect almost. So I'll grab that. And we'll have a couple of different options for what color that offset should be. So we can have a white offset, which will get kind of like an accent. We have a black, which will look like a shadow. Or we could even use our complementary color by picking the color that's 100 degrees away from each individual shade. So let's take a look through these, and we'll have Dana make the final decision. So here's what the accents kind of look like. And in this case, since we picked a diamond, it's only showing up on one side. So we can even tweak our offset a little bit if we want the accent to show up kind of fully to the right or fully to the left, something like that. Here's what the shadows would look like. And then here's what the crazy complementary colors will look like. So a bunch of greens, because that's opposite of where we are at that color wheel. Do any of those options appeal to you, Dana?
I like the first one where the white was
Okay,
the
cool.
shade.
And should we offset the shadow a little bit, or do you like it just on the one side? This kind of looks more isometric, which is actually cool as well.
And that's what I like. So
Okay, perfect.
thanks.
Yeah. So that's it. We've generated some art, and we'll save this and distribute it for everybody to save and use as their desktop background. So that's all I've got. Thanks for attending. If you've got the slides pulled up, you can grab this image out of there and do with it whatever you wish. Thank you in particular to the DevCon team for helping me out with that live feedback. I would love to talk to anybody about generative art. If you have any other questions, please email me, ping me. That'd be awesome. And I've got a couple references at the following slides here that you can scroll through if you want to as well. Thanks, everybody.